So I'm going to introduce the Xenus Compact, some new features about this Xenus Compact. Of course, most strikingly is the size. It's about as big as my voltmeter here. The standard Xenus, this can deliver about as much or more continuous current than the smallest of the standard Xenuses. So for the size, this thing really packs a wallop. There's an internal heatsink and a fan. I haven't actually delivered enough current yet to make the fan come on, but I'm sure they've tested it and it works just fine. Another interesting feature is the positive locking on all the connectors. If you have to use the Xenus as a stepping ladder to climb around on your machine, the cables won't come out. STO, safe torque off, SIL 3, category 3. The metal covered drives all meet the latest TUV standards for safety, so this is a good stow feature on this drive. Regen is internal and integral to the drive. It's 20 watts continuous. At 390 volts and 60 ohms, that's about 2.5 kilowatts of peak regen power. So all the power you push out, you can take back. That should be a healthy amount of regen in the drive. I do like to talk about cabling, grounding, and shielding. So just make sure you've got earth to the case. The motor case finds a path to earth. There's a earth ground here, but when you bolt it in, it should find a path to earth. It's good to have earth at 24 volts, earth at the controller. The feedback shield absolutely must find a path to earth. Protective earth comes in with AC power. That's a good idea. There's a cool new socket for connecting earth to the case. So you just need a number 832 screw and connect earth to the case. That's a handy feature. Some mention of spacing in the drive, and of course, serial cable kit for connecting the serial. There's a connector kit that has all the connectors you need to get the drive up and running. So I'm going to show a little bit about the cabling here. I've got the case of the drive connected to earth, so that any switching noise finds an easy path to earth. You can power the drive with a 24 volt power supply. That's a keep alive. I use Meanwell 24 volt supply. It's a good power supply manufacturer. They make a lot of good power supplies. So I've got the 24 volts connected here on this little Wago connector, and there's a little tool for opening the socket and putting the wire in. If we wired it up with just 24 volts, we could then communicate to it over RS-232. I'm using a B&B USB to serial adapter, US09ML2. There it is. So the USB to serial adapter connects to the serial connector kit and allows you to talk to the drive. Before I connect the power, I'm going to connect the feedback. You do not do hot swapping, so do not connect the feedback while the drive's powered up. Again, there's a little tool for the motor power, and you can see the green wire is the earth for the motor, so the case of the motor finds a path to earth. It's idiot-proof. You can't plug it in backwards. Yes, a line filter. Here's a good one. Corcom. Other people make them. This for emissions. It is a PWM amplifier, so you want to. It's a quiet amplifier, so there's not a lot of noise, but the standards demand filtration, so there it is. In order to enable the drive, I need to connect the 24 volts. So the light comes on. I should be able to talk to the drive now. So let's see if we can connect. Connect over the COM port here. And I've got some conditions that prevent me from running properly. I have a encoder fault. I'll clear that. I've got the stow. I've got a little adapter here. So I'm going to connect that. Safety bypass jumpers here. That's indicated in the data sheet, what wires to jumper together. Flashing green light. No faults indicated. That's good. Can I enable it? Yes. Green. Solid green light. And I can jog it. That's good. So I have a little time, so we'll hit some of the cool features of the Plus drive, all Plus drives. There's some absolute encoders. This one's got an absolute A. And on the motor data for the quick servo, we can see it's a 20-bit. That's 1 million counts per rev. And 65536 turns of multi-turn. So 1 million counts per rev for 1 rev of the motor. 8-pole motor. The Plus drives have some pretty fancy filters. The default for the low pass filter is 200 Hertz 2-pole, but during the tuning we moved it out. It's single pole, Chevy Chev. You got notch filters, band pass, no filters. There's some input shaping, multiple loop filters. I've done a little bit with filters for various mechanical resonances, a little bit of input shaping, but for the most part, just move the velocity loop filter out to maybe 200, 300, 400 Hertz. Single pole low pass should be fine, unless there's some mechanical resonance around that area, then pull it back to 200 Hertz. So as this is a Plus drive with an absolute encoder, we'll take a quick peek at the manual phasing with an absolute encoder. I can enable a vector of current, motor phase angle in black, feedback angle in red. As I rotate the current vector, let's give it a little bit more current here, 1 amp. We can see that the feedback follows right in line with the current vector. So we can determine that we're phased properly. When we go forward, count should go up. Everybody gets a turn at delivering plus or minus an amp. If there was an inversion, you could invert the motor, or the feedback, or adjust the offset. You can set the 0 position. Let's not encoder 0 because I don't want to defeat the manufacturer's settings. The manufacturer mounts the encoder according to a procedure, and that's with respect to the electrical cycle. I will, however, show you the homing method, which is preferred. So you can home immediately with an absolute encoder, and so on power up or reset, you're home, and you don't have to move to get there. You know where it is. So if I powered up in a position other than 0, I'm in this actual position. But if I want this to be 0 over here, then maybe I want that to be 0. I'd have to put in the inverse of that, 5, 3, 1, 5, 9, 7. Okay, I saved that, so I'm going to home. So I'm over here, and I home. Home reference calibrated. So I come back. 0 position with respect to where I was. We'll look at that in a different way. We'll reset the drive. It asks the encoder where it is, and then it adds the offset. So thereabouts is the 0 position. So if I'm somewhere else and I reset, I'm in some other position with respect to 0, but there's my 0. So it's absolute immediate home. So another feature of the Plus drive is the encoder status. A battery warning tells me that my battery's getting low. I don't actually have a battery here, so I could ignore the battery error, and that means it's just absolute within 1 rev, not multiple revs. If I did disconnect the encoder, maybe I should get a fault. Now, encoder error. Can't clear that fault. Feedback error. CRC error. So the data is not correct for the feedback device. That could be cabling, shielding, grounding, or that could be disconnect. Or it could be we haven't entered the proper data, but it was working a moment ago, so the data's good. And again, never hot swap. Back to the battery warning, which is fine. It's just a warning, not a fault yet. But I should address getting a new battery in something here. Okay, before we go, we're just going to take a quick measurement to earth here. So I've got earth connected to the case. I got continuity from earth to the case. The motor case should find a path to earth through the earth wire on the drive. Located here. The connectors, so the feedback shield should find a path to earth. 24-volt supply is not finding a path to earth, so that's something I need to address. But all the shields will find a path to earth, so that's good. Protective earth, also connected to earth. So this is a good setup for low noise. You won't get corrupted feedback data. You won't get the CRC fault on the feedback. Yeah, the switching noise will find a path to the case. That's good. If you did have a shield on your power cable, there is another ground connection for a shield there. Ground for the motor. You can hook up the earth to the 24-volt here. There's a return line and a break output. And the jumpers for the stow. Some switches for, this is actually an EtherCAT drive. And so I have switches for the alias. First node will be -1, the second node will be -2, and you can adjust node aliases with the switches. Well, that's it for today. Thank you again for looking at the new Xenus drive, Xenus Compact, and weighs less, so it should cost less. Good drive for the market. Thank you very much.